In this video, we're going to combine the ideas of composition of functions and inverses. We're going to focus on verifying that two functions are inverses of each other. And to do this, if the two functions are inverses, then their compositions are the identity function. What this means is if I have my function f and its inverse, and I take f of the inverse, my result should be the identity function, which is x. So everything should simplify and just give me x. And the same thing should happen if I do the inverse of f. Everything should simplify and just give me x. Both of these need to occur. So in the first problem, I'm asked to find the inverse and then verify it is the inverse. So remember, to find the inverse, you switch the x and the y variables and then solve for y. So f of x is another way of saying y equals, so we have switched the x and the y, x equals negative 3y plus 7. Well, I would subtract 7, x minus 7 equals negative 3y. Divide everything by negative 3, and so y equals x minus 7 over negative 3. And I'm just going to leave it as is. And so here's my inverse. If you want to change it to slope intercept form, you could do y equals negative 1/3 x plus 7/3. But I'm going to focus on using it in this format. And so now I'm asked to verify that my f of x and my y equals x minus 7 are in fact inverses. And so to do this, we take the composition both ways. I first am going to take f of the inverse. And so that means wherever I see my x in f, I'm going to replace it with my inverse. So I have negative 3 times, instead of x, I'm going to use x minus 7 over negative 3 plus 7. And so if we take a look, negative 3 and negative 3 are going to cancel. And so I have x minus 7 plus 7, which the negative 7 and 7 cancel, and I'm left with just x. And that's what our property says, is that if they are inverses of each other, if two functions are inverses, when you take the composition of it, you should get x when you simplify. And so that works there. Now I'm going to have to repeat the process, and this time do the inverse function of f of x. So this means in my inverse function, y equals x minus 7 over negative 3, wherever I see my x, I'm going to plug in my function f, which is negative 3x plus 7. So I have negative 3x plus 7, that's this x, minus 7. So I'll put a parentheses so we can see where the x is, minus 7 over negative 3. Well, the 7 and the negative 7 cancel each other out, and you get y equals negative 3x over negative 3. And these cancel, negative 3 over negative 3 cancels, and you get y equals x, the identity function, just like before. And so we did verify that these are, in fact, inverses of each other, because when I took the composition both ways, f of the inverse and the inverse of f, they all simplify to give me the identity function, y equals x. So that is a way to prove that you have two functions that are in fact inverses of each other. You take the composition both ways and make sure everything simplifies to give you the identity function, which is the equation y equals x.